So the derivative of the integral from 7 to x. So I don't really want to take the antiderivative of this and then take its derivative. That would be the long way around. What's the shortcut here?
Sub it out for x.
Yeah,
Sub
just
t out for x.
plug the x in for t, because the derivative of the antiderivative cancels each other out. So 3 over x squared plus 3x. The next one looks awful.
But it's not.
But again, take the big picture of what's going on here. You're taking the derivative of an antiderivative. Those should cancel each other out. Mostly, but we do have to plug in, whoops, not into there. So e to the cosine of 5x.
So u just means pi in this case?
We don't have to worry about the bottom because that's a constant, so I don't have to worry about it.
Oh, duh.
Alright, but there's a little bit of a trick coming on the next one. Derivative of the integral. Okay, that's fine. That should cancel each other out, but
Why is it bigger?
there's something weird going on here. Well, it starts out the same. So 5 times 3x squared plus 1. But I've got to account for the derivative of this guy.
So you antiderivative?
Not antiderivative that guy. I need to take the derivative of that guy.
Okay.
So it's a chain rule thing. The derivative of the top would be 6x. So it's a chain rule thing. It's the derivative of the antiderivative cancels each other out. That's fine. But chain rule, multiply by the derivative of the top. An even better way to do this, or to think about it, is to do top minus bottom. So now let's plug in the bottom one. 5 times 3 plus 1. And then what's the derivative of the bottom one?
Turns into
0.
0.
So there's why, if the bottom one's a constant, it zeroes out whatever else was going on, because it doesn't matter. So that part, that whole chunk of stuff goes away.
So it doesn't matter?
If it's a constant, it doesn't matter. But if you want to just memorize sort of the overall rule, then plug in the bottom one and multiply by the derivative of the bottom one. And if it's a constant, it goes away. Same thing for the top one. If the top one is a constant, it would go away. What if the lower boundary is not a constant?
Doesn't matter.
Well, that's fine. Let's follow the same pattern here. The derivative of the integral cancels each other out. So I'm going to have e to the, in place of t goes sine of x. Careful, there's a squared on that. So e to the sine of x squared. But then I have to chain rule it. And as usual, the chain rule is what people forget. What's the derivative of sine? Cosine. Yeah, it's not that people don't know the derivative, it's that they forget to do the chain rule.
E multiplied by 1 times cosine, the power of cosine, or just cosine?
It's just multiplied by cosine of x. And then minus, plug in the bottom one. So e to the x squared. Chain rule, what's the derivative of x?
2. Or x squared is 2x.
Well, I don't want the derivative of x squared though, I want the derivative of x. So 1. Okay, so here's the big fancy way to say fundamental theorem of calculus part 2. They're both the fundamental theorem of calculus. Part 1 we already did. This is part 2. Let's see. Derivative of the integral cancels each other out. Plug in the top one. So that would be f of g of x times the chain rule, so times g prime. This is harder to write than it is to think about. Minus, now the bottom one, plug in h of x, so f of h of x times what? H prime. Good. So back up big picture a little bit here. So fundamental theorem of calculus part 1 was that the antiderivative of the derivative is back to the original. Either plus c or the f of b minus f of a. Part 2 is sort of the backwards, instead of the, not backwards, the opposite direction, the opposite order. Instead of the antiderivative of the derivative, it's the derivative of the antiderivative of f of x equals f. But chain rule, so you got to be careful. So that each of them have a little twist to them. So yeah, the antiderivative of the derivative gets you back to the original, either with the plus c or with the limits. The derivative of the integral gets you back to the original, but don't forget the chain rule. That's sort of the first 3 days of the unit right there. 75% of the unit is right there. Now, obviously, there's a lot going on in the background there, but that's it. And that's why, excuse me, different teachers call it different things. It's not the first and second fundamental theorem of calculus. They're not listed separately. They're both the fundamental theorem of calculus.
They just break them up into...
You just say it 2 different ways. It's basically just reminding you that the antiderivative of the derivative gets you back to the original, and the derivative of the antiderivative gets you back to the original. And you'll never have to remember, like, oh, which one's part 1 and part 2. It doesn't matter. Okay, the second thing, and really the last new thing of the unit, is average rate of change. Yes, A-Rock. So that's just the good old algebra slope. So the average rate of change from excuse me, that's not the new thing we're doing today. We're going to head toward average value, not average rate of change. But we'll start with average rate of change and work our way to average value. So average rate of change, A-Rock, algebra slope, change in y over change in x, right? There's like 5 different ways to write that in Algebra 1 class. Probably the fanciest way is how we'll do it. F of b minus f of a over b minus a. Remember, that's Algebra 1 with a fancy name attached to it. Average rate of change. Alright, now we know, this is FTC part 1 here. It's a little bit out of order than what we usually do. The antiderivative of the derivative gets us back to the original. top minus bottom. So I can replace f of b minus f of a with that thing. So the average rate of change on f is, instead of f of b minus f of a, I'm going to go the integral from a to b of f prime of x dx over b minus a. And you should be thinking, why in the world would we do that? Because you just made it way more complicated.
Because math.
Because math is a good enough answer. Right? If you had f of b minus f of a, what are you messing with f prime? Well, hang in there. And we usually end up putting it like this, 1 over b minus a times the integral from a to b f prime of x dx.
I'm assuming this has to do with the average value.
Okay, so now we get to some words. We're going to do some word substitution here. The rate of change of f is f prime, right? That's what f prime means.
The instantaneous rate.
Yeah, the IROC of f equals f prime. So that means that what we just found is that the rate of change of, what are we saying here? So all right, this was our rate of change up here. That's what we found. We just wrote it a little bit differently. So if we replace rate of change of f with f prime, rate of change of f, that's the same thing as f prime. Means the average f prime is the same thing as the average rate of change of f, which is what we already wrote. So 1 over b minus a one more switch. If we just wanted to trade out f prime, instead of writing f prime, if we want to put a different letter in there, like g,
Like value.
the average value of g, one over b minus a, integral from a to b of g of x dx.
So that's what we're supposed to put in this big box down here?
That's what's going to be in the big box. Let me show you a slightly different way to get there that I think is maybe easier to understand. Let's say that this is g. And we want the average value from a to b. The average value from a to b. So that would sort of be the average height. What would the average height be? Well, one way to do that would be to take the area, which is an integral from a to b of g of x dx. That's the area.
Divided by x.
And divide it by
Change in x.
change in x.
So that would be
So that's more how I remember it. That's a long derivative. The average value is the area divided by b minus a. So 1 over b minus a times the integral from a to b of, whoops, we're in f, not g now, f of x dx.
F prime x dx.
No, because when we had f prime, that was the average of f prime. We didn't want to nest too many f primes, so we just swapped it out.
Oh, okay.
So to me, this area thing is the best way to remember it. It's the area divided by the width would give you the average height, right? Because if it was a rectangle, you would just do area divided by width equals height. So that's what you're getting at. The average height is the area divided by the height. So whether you remember it this way as area over b minus a, area divided by width, probably nobody's going to remember all that derivation stuff. This is the easier way to think of it. Or whether you just forget about the area and just straight memorize the formula, you've got to know this. This is always, always, always on the AP exam, and usually several times. Sometimes even on the free response part, but definitely on multiple choice. Probably both more often than not. All right, so 2 things today. So the second part of the fundamental theorem, and this is one of the easier things we do, right? Just the derivative of the integral, it gets you back to the original. Don't forget the chain rule. And then the second part, the average value is the area divided by the width. Let's do some examples here. I think the examples are easier than the derivation of the thing we've been doing. So number 1, and the trick is, if you forget to look big picture at what's going on, then you end up trying to work from the inside and think, okay, let me take the antiderivative of the square root of 1 plus t squared. And you're like, I don't know how to do that. Well, they don't want you to do that. They want you to see big picture. What's going on is the derivative of the integral. Like, oh yeah, that means they cancel each other out. So all I have to do is plug in the top. And I guess it's probably safer to think about chain rule every time. So what's the derivative of x? 1. So if we forgot the chain rule on that one, we'd be fine. Minus, plug in the bottom. Now some of you are going to skip this step sometimes. Why are you going to skip this step?
Because it's a constant.
It's a constant, which means the chain rule gives me 0. So we can kind of, you can leave that there. That sort of emphasized you knew exactly what you were doing. So free response answer, that's a good safe stop. Multiple choice, they're probably going to clean that up a little bit and just do square root of 1 plus x squared. So slow and steady initially. Once you get the hang of it, then you start knowing the process and you may skip to that final answer. Number 2, again, big picture. Don't try to take the integral of tangent because we don't know what the integral, right? All those trig functions, none of them had a derivative of tangent. So we couldn't take an antiderivative, but we can do the derivative of an antiderivative. Those cancel each other out. Tangent of natural log of x. That's a little bit weird, but times 1 over x, because the derivative of natural log of x is...
So could you just write over x?
So you could just put all of that over x, yes. I'm sort of emphasizing the piece by piece of it here. All right, do you want to plug in 4? Or can you give me a reason to skip that step?
It's a constant.
It's a constant. So the chain rule of 4 would be 0. So if you want to write it out to kind of convince yourself, fine. If you want to just skip it because you know it's going to give you 0, that's fine too. And yeah, you could just write that as over x. But those are the same thing, so either way. Why don't you try number 3? Although it's got a top and a bottom, so there's no skipping things on number 3. Try number 3. Number 4. Number 4, we hadn't done one like number 4. Thoughts on what's going on with number 4?
7. We're going to get to skip something because there's a constant.
Your stuff. I feel like you just do the same thing.
You kind of just do the same thing. It's going to end up a little bit backwards because we're going to have, I could plug in 2, but I don't really need to bother with that. Because what's the derivative of 2? Of negative 2, I should say. It's 0. So I'm not even going to mess with it. I know I'm multiplying by 0, so pass. But it does mean I'm subtracting the second one. It's a weird one. The cube root of 1 plus cosine x squared times, let's see, the derivative of cosine is negative sine x. Now that definitely has some cleanup work, although that would still be an okay free response answer, even with that blank in there, because you put the 0 on, so he wipes it out. Multiple choice. 2 negatives make a positive, and we'd probably put the sign in front to make a little more clear what's going on. We might even be fancy and put the square right there on the cosine. Right, that's the same thing.
Wouldn't the inside the radical be sine squared? Because 1 plus cosine squared.
No, because sine squared plus cosine squared is 1.
Oh, it'd have to be minus.
It'd have to be minus. Yeah. Number 5. If g of x is this thing, then what is g prime of x?
The thing we put in the big box on the other page.
So I want to find the derivative of g.
The antiderivative?
No, I want to find g prime, so I'm going to take the derivative of both sides. Take the derivative of both sides. That will force g prime to show up. So left side's easy. Turns out the right side's pretty easy too.
Yeah.
So this is just like 1 through 4. They just tried to ask it in a weird way. The derivative of the integral, those cancel each other out, except that I need to plug in x. So f of x. And then chain rule. What's the chain rule? Get me. 1. At some point we, again, stop writing this stuff, but what about the 1 at the bottom? Do I need to consider that? I guess that's a bad way to ask that question. I do need to consider it.
Technically not.
But when I consider it, it's 0. Minus f of 0 times 0. So all of that to say, the answer is just f of x. Because the antiderivative of the derivative gets us back to the original. Don't forget the chain rule. All right, some average value problems. Average value. Let's just write the formula over one more time, because writing it helps it get in your brain, and it's not on this page yet. So it's 1 over the width times the area. 1 over the width times the area. Okay, so for this problem in particular, 4 minus 1, integral from 1 to 4 of 3x squared minus 2x. Okay, so this is just not hard, but a lot of antiderivatives by hand here. No, I'm ready to take the antiderivative. So, I love it when they're kind to us like this. Sort of rig the problem here. Landon, what's the antiderivative of 3x squared? X cubed. Mia, what's the antiderivative of 2x? X squared. And then we'll do that from 1 to 4. So 1/3. And then I'll plug in the 4. Just trying to think, do I want to be lazy or do I want to cube the 4? Being lazy would just be writing 4 cubed and 4 squared.
Yeah.
But 4 cubed is 64. That's not too bad. 64 minus 16 minus 1 minus 1. Is that a safe stop?
Yeah.
Yeah, there's no, I mean, that's just calculator ready computation stuff.
And if we wanted to.
But multiple choice would be 1/3 of 64 minus 16 is 48. And 1/3 of 48
I don't know.
is right. I don't know either. I mean, I do know, but you'd be safe stopping that if you had the chance.
You could go up to the side and long-handed like Renault in high school.
Yes. Oops, I don't want to pause yet. All right, I'm going to pause, and you're going to try number 7. So see if you can do 7 start to finish. It's exactly like number 6. I mean, different numbers, different equation, but same process. Find the average value of f from 0 to 3. So the answer is 6. Again, most of you had the formula right, but you were doing all sorts of little bitty mistakes in there. 3 cubed is, in fact, 27.
Yeah.
That was a few people. The antiderivative of x squared is x cubed over 3. There was just little bitty stuff. A few people left it like right there, which is fine, because that's a safe stop. Any questions on number 7? Anybody not get it and not understand why they didn't get it?
No.
Number 8, calculator. That's probably good news. On the interval 1 to 2, what is the average value of h of x? Well, the average value is 1 over the width times the integral. But it says use a calculator, so I don't have to take an antiderivative by hand. I can let the calculator do the hard work. 1 over 1. I don't have to worry about that. So it's just how fast can you type things in the calculator. That should be the answer, whatever that is. Whoop, 1 to 2, yeah. Good catch, good catch. 1 to 2.
Yay.
And in terms of showing work, you would need to show this, because you need to show the grader what you've done, but you don't have to do it by hand. After that, the calculator did the work. So show what you put in the calculator, but you don't have to show anything more than that, because the calculator did all the work. Number 9, find with calculator, so that's good. Find the value of k such that the average value of f of x equals sine of x on the interval 0 to k is 2 over pi. Ugh. Okay, well, let's start with average value formula, and then we'll plug in what we know. So the average value is 1 over the... Oh, here we go. How wide is this interval? 0 to k.
Know.
Well, we don't know, but we can express it in terms of k.
K minus 0.
Yep, 1 over k. Integral from 0 to k. Sine of x dx.
Equals 2 over pi.
Equals 2 over pi. Oh, so they're telling me the answer. So, yeah, thanks for the calculator. It doesn't do me any good right here.
It doesn't?
Not yet, because my calculator can't do the antiderivative from 0 to k. I mean, it might give you an answer, but I need
You need something
I
definite.
need something in there. So 2 over pi equals 1 over k. We gotta do this by hand. The antiderivative of sine
Cosine.
is not cosine. Negative cosine.
Oh.
0 to k. Yeah. Thanks for nothing on offering me the calculator so far. So negative cosine of k minus negative cosine of 0,
Which is plus 1.
which is plus 1. So 2 over pi equals 1 over k times, I'm going to sort of rewrite this, 1 minus cosine of k. Okay, now I see why I get the calculator, because how else am I supposed to solve for k in that thing?
I don't know. Figure it out.
So how do you use a calculator to solve for stuff, to find a value? Plug it into where? I mean, yeah, I'm going to plug it in, but
The calculator, I guess?
let's set it equal to 0. And that way we'll look for where that thing equals 0 on the graph.
Alright.
Lovely. 1 over
Make sure you're in radians.
1 over x. Yeah, I do need to be in radians because I was in pre-cal earlier. So 1 over x, parentheses 1 minus cosine x. Careful with parentheses there. Make sure you close them all.
Yeah.
Minus 2 over pi. I want to know where that's 0. But it's got to be between 0 and k. Of course, I don't know where k is, but I don't need to go left of 0. Oh, how far out to go? I'll go to, I guess I'll go to 10. We'll see. I don't know. I don't know how far out to go. My y, as long as I'm seeing 0, I don't care what it does way away from 0. I just care where it's equal to 0. Okay, so it looks like there's 2 answers there. I'm going to tweak my window here to get a better look. Let's go 0 to 5. And I'm going to change my y min and y max just so I get a better view of things. Goodness, I could zoom in some more and be okay. Like negative 0.5
I went
to
negative
0.5.
1 to 1 and
That way you can more easily see the. So now it's just using the calculator to find the zeros. Second calc 0. Left bound, right bound, guess. 1.571. Which I think that's pi over 2, but it doesn't matter. Second calc 0. Find the other one. Left bound, right bound, guess. 3.14159.
pi.
Pi. 3.142. So I think my answers are pi over 2 and pi, but it doesn't. It said use a calculator, so we'll get decimal answers. I'm not trying to find the exact values. So that was a weird one, but you had a calculator. By the way, on the AP test, your multiple choice with calculator, you get 2 minutes per problem.
What?
I think it's 2 minutes. And multiple choice, no, with calculator is 3 minutes. No calculator is 2 minutes. So they give you extra time when you have the calculator. So it's not supposed to be a race of who can punch in the calculator. They try to factor that in so that you can do the graphing and the left-bound, right-bound stuff and all that. All right, your assignment today is worksheet 3. Most of those are very straightforward. There's a few weird ones on there. So try worksheet 3, and we'll start reviewing tomorrow. So, kind of nice. We're done with new stuff until the test.
About your project.
Yes, project due Monday. Project due Monday.